This is a system of equations by substitution that ain't gonna be so bad. I'm gonna call you A and B and C. What I see is B is already solved for Z, so I want to take turns with A and B, and then B and C, and plug in Z for those Z's. Now here's the thing. The goal of all of this is to come up with two equations where now I only have two variables. Well, look at the top equation. That's already two variables. So I'm going to leave that as is. So I'm going to go with U. I'm going to leave it there. Now, I still have to use B and C and plug in that guy for Z down there to get me just X's and Y's. So I'm going to do that. So I'm going to set up B and C. So B is Z equals negative 3X minus 3Y plus 9. C is negative 4X plus 5Y plus Z equals 8. Okay? So if I replace the bottom equation, the Z in the bottom equation with the Z up here, I get negative 4X plus 5Y plus Z, which is negative 3X minus 3Y plus 9. And then to complete C, I have equals 8. Okay, this parentheses, not useful. So negative 4X and negative 3X is negative 7X. 5Y and negative 3Y is 2Y. And if I subtract 9 from both sides, I get equals negative 1. So I have my top equation, and I'll write that directly underneath to create a new system of equations. So I have 7X minus 3Y equals negative 6. Now, going with the spirit of substitution, I'm going to use substitution to solve this system of equations. So why don't I take the top equation? Why don't I take the bottom equation and solve it for x? That might be easier. If I solve the bottom equation for x, right, let me just rewrite it out. 3x minus 3y equals negative 6. If I solve u for x, I'm going to add 3y to both sides. 3x equals 3y minus 6. Divide everything by 3. X is going to equal y minus 2. Let's take that and plug that into the top equation. That's going to get us negative 3x, which is now y minus 2. So let me replace the x with y minus 2. So negative 7 times the quantity y minus 2, close it, plus 2y equals negative 1. Distribute, negative 7y plus 14 plus 2y equals negative 1. Combine like terms, negative 5y plus 14 equals negative 1. Subtract 14, that gets us negative 5y equals negative 15. Divide by negative 5, divide by negative 5, y equals 3. Now, I know that x equals y minus 2. And if I just found out that y equals 3, that means x equals 3 minus 2. Which last time I checked is 1. So I have my x, I have my y, I need my z, and z just so happens to be equal to negative 3 times x minus 3 times y plus 9. So z is going to equal negative 3 times x, which is 3 times 1, negative 3 times 1, minus 3 times y, which is negative 3 times 3, plus 9. So z is going to equal negative 3 minus 9 plus 9, so these guys will just cancel each other out, and z is going to equal negative 3. So putting it all together, okay, my x was 1, my y was 3, my z was negative 3, close you up, that's my guy. So solving a system by substitution, not the prettiest thing in the world, lots of work here, but boy did I have a lot of fun.